Hey guys, and welcome to lesson 14. Today we're going to be talking about summing independent random variables. So let me remind you of what an indicator function is first. So remember that the indicator function is written as like 1 sub a of x, where a is a set, and the function is 1 if x is in the set, and it's 0 if x does not belong to the set. So a pretty simple concept, I hope. It's just kind of indicating if something belongs to a set or not. And whenever I brought this up in class, we talked about how it can be used to change integrals so that all your integrals can go from minus infinity to infinity, and we don't have to worry about the range. So instead of integrating from a to b, we integrate from negative infinity to infinity, but we multiply by the indicator from a to b, so that everything outside of that interval is just set to 0, and there's no area. I'm also going to point out a useful fact that if you take the indicator of A and multiply that by the indicator of B, you get the indicator of A intersect B. So let's think for a second about why that would be the case. If either one of these numbers on the left is 0, then the product is 0. Right? So the only way you get a 1 is if the indicator of A is 1 and the indicator of B is 1. Well, if both of those are 1, that means that x is in A and x is in B, which is just the same thing as saying x is in the intersection of A and B. Okay, so one other concept we're going to need is something that's probably going to be new to most of you. This is called a convolution. So given two functions f and g that map to the integers, the convolution is a new function, so it takes two functions and makes a new function, f star g. And sometimes we'll write it as like capital F of x. So it is, or I'm just using this to show you that it is a function, in fact. And what it's going to be is the sum from I equals negative infinity to infinity of f of I times g of x minus I. So notice that we're plugging x into the function, and then there's one x inside of the g function. But what these two values have to do with x is that if you add them, you always get x. So I plus x minus I equals x. And that is the sum of these two inputs is always fixed at x. We can do a similar thing if the functions go to the real numbers. So if we have functions on R, then f star g of x is going to be the integral, rather than the sum, as our usual thing, of f of y g of x minus y dy. And again, you're plugging x into the function, and so the sum of the two parameters in f and g is always fixed to be x. So let's do a couple of examples. Let's say you get phone calls at a rate of 2 per hour, and so the number of phone calls you get in the next hour is a Poisson random variable with parameter 2, and therefore the PMF for x is 2 to the k over k factorial e to the minus 2. Well, let's say you have a friend and she gets phone calls at a rate of 3 per hour. Then the number of phone calls she gets in the next hour is Poisson with parameter lambda equals 3. So we'll have her random variable is going to have PMF 3 to the k over k factorial e to the minus 3. The question is, what's the probability that between the two of you, you get a total of 2 phone calls in the next hour? So it turns out that the PMF of the sum of x and y is going to be the convolution of the two PMFs of x and y. And so this sum, rather than going from minus infinity to infinity, I'm going to plug in zeros, where the PMFs are zeros. So we only go from 0 to k of the probability that x equals I and y equals k minus I. So for the k phone calls, you'd think of this as like you get 0 and your friend gets k, or you get 1 and your friend gets k minus 1, and so on. So that the sum, or these two parameters, are going to add up to k, but it's all possible ways that that can happen. So to get exactly 2 phone calls, either you get 0 and your friend gets 2, or you get 1 and your friend gets 1, or you get 2 and your friend gets 0. So one of those things must happen to get exactly 2 phone calls. And so we're going to have to add up all these probabilities. The total probability is the probability you get 0 and she gets 2, or you get 1 and she gets 1, or you get 2 and she gets 0. Okay, so we're not going to bother plugging in the numbers at this point. I just want you guys to have a good concept of what a convolution is, and finding the PDFs and PMFs of a sum of independent random variables. So for example 2, we're going to suppose it's raining where you are, and the amount of rain has the uniform distribution over 2 to 5 inches. And they're predicting rain tomorrow, and the rain tomorrow is going to be uniform over the interval from 3 to 7 inches. What's the probability that the total amount of rain you get in the next 2 days is at least 8 inches of rain? Well, for a uniform distribution from over the interval 2 to 5, your PDF is going to be 1/3 times the indicator from 2 to 5 of x. And for the uniform over 3 to 7, it's going to be 1/4 times the indicator over the interval 3, 7. Okay, and once again, if we sum the random variables, the PDF is going to be the convolution because we need the two values to sum to the total. So we need x to be some value y, and that's confusing. So by that I mean the random variable x is going to take on a number y, and the random variable y will have to take on the number x minus y. So these two x minus y and y have to add up to the value x. And using this we can find the PDF for the sum of x plus y. So we could take the 1/3 and the 1/4 and bring that out into the front, and that gives us a 12th. And then we have the indicator from 2 to 5 and the indicator from 3 to 7. And I have to be a little careful here. I told you earlier that whenever you multiply two indicators, you just intersect the two sets. But that's because they had the same input. Now we're intersecting the indicator of y and the indicator of x minus y. So before we can intersect the sets, you also have to make a substitution, so that this is just a y also. And whenever you make that substitution, you'll get the interval from x minus 7 to the maximum between x minus 7 and 2, and the minimum between x minus 3 and 5. And breaking the interval into 3 pieces over which one's going to be the maximum and which one's going to be the minimum, you end up getting the following PDF in 3 pieces. So, using this PDF function, the probability that the sum of rain that you're going to get over the 2 days is at least 8 would then be the integral from 8 to infinity of that PDF function, which from 8 to 9 is 1/4, and from 9 to 12 is 12 minus x over x. Oops, I'm sorry, that's a typo. It should be 12 minus x over 12. So this x on the denominator here should be a 12. And so the integrals aren't so hard to do. This is 1/4 from 8 to 9 is just going to be 1/4. And 12 minus x over 12, well, you're going to get, just the 12 is going to stay there, and then it's going to be x squared over 2 here for the x. With the 1/12, you could bring it out front or something. So just do regular integration, but this should be a 12, not an x. And then you're going to get 3/8. And 3/8 and 1/4 gives us 5/8. So that computes the total probability that we're going to have at least 8 inches of rain in that scenario. Okay, so that's all about this topic. I'll see you guys in class.